Hello, everyone. Welcome. Hope you're all doing great. Today is going to be the finale of the Wintermute MEV Hackathon with Flashbots. I'll let a few more people join in here, but really fun day today, finally kicking off all the hard work that has gone on throughout the hackathon. Let me share my screen here 1 second. And maybe make OMG the host in case there are more individuals coming. Well, first off, congratulations on making it to kind of the finale and prize giving ceremony. This is the Encode Wintermute MEV Hackathon with Flashbots. Today, we'll kind of go over a few things and you'll see all the finalist pitches. So first off, a little bit about Encode. If you don't know us already, we're a Web3 educational community. We help train awesome developers into Web3 at scale. We're industry-leading education partner, partnering with the best protocols and chains. We're totally free, global environment and ecosystem, and we help people raise funds to get jobs. So pretty cool stuff. Hackathons are one part of the events that we put on. So what is happening today? We will have 11 finalists pitch live in front of judges, in front of the audience here today, in front of our team, following a Q&A session. And then after, we will actually announce the prize winners live and showcase kind of those prizes for everyone on display. So first off, can we have a few words from our title sponsor, Wintermute today? Jonas.
Sorry, guys. I was looking for the unmute button. First of all, thanks for all the submissions. It's been highly appreciated on our side. It's pretty amazing to see the finalists come through. So that's much appreciated. And thanks for all the hard efforts here. I know there's been some proper coding going on over the last few weeks. And also thanks for the Encode team to generate such a good event. Well, just a quick intro. I sit and head up Wintermute Ventures. I've spoken with a few of you guys in the session a few weeks ago. I'll be one of the judges today. And then we also have Felix from our side, who's part of our DeFi team and is a bit more technical. So he'll be here to also judge from that aspect as well. And then I think we have Brock from Flashbots as well.
Great. Thanks so much.
Brock, want to say a word too?
Yeah, sure. Hey, everyone, I'm Brock. I'm an engineer at Flashbots. I focus on searcher experience, so kind of all of our tools on a high level. I checked out all the projects. A lot of them I really liked. I'm really excited. I'm sad that we only can choose one winner. So yeah, very excited to get into it.
Thanks, guys. Big thanks to our partners, our sponsored partner, Wintermute, and our educational partner, Flashbots. Could not be possible for this hackathon without you guys. A little plan of action today, what is happening. We're going over the overview of the hackathon. Then just shortly, we'll get right into the finalist pitches. And then after all the finalists have finished their presentations, we'll actually deliberate within the judges in a breakout room. And then within 10 minutes, we'll actually crown the winners. So pretty quick stuff today, jam-packed. So stay tuned for a lot of good presentations. What was the MEV Hackathon? First off, it was a 4-week all-online hackathon to learn and build on all projects MEV, anywhere from mitigating MEV to extracting the most value as possible. This was your chance to kind of work with it, learn throughout the process, get unlimited support and great workshops from Flashbots as well as Wintermute, and then finally kind of win some great prizes. So a reminder on the prizes, we have 3 prizes available, first, second, and third, all denominated in British pounds, 15,000 for grand prize, 5,000 for second, and 2,000 for third. Who are the judges today? I know Jonas kind of mentioned this briefly, but we have Brock Smedley, searcher experience engineer at Flashbots, as well as Jonas, who's on the VC and M&A side at Wintermute, and an algorithmic trader at Wintermute with Felix. So combining all those kind of technical and non-technical spaces here for a great judging kind of panel. Very cool stuff. And a reminder on the challenge, it was just the best project using MEV. We wanted to see anything from research pieces to DeFi protocols that use or address MEV, use of Flashbots auctions, or even just using and kind of determining MEV data. Then now we'll head over to the pitches. So we will start off with the team at FairTraDEX or TradeDEX, however you pronounce it. I think we have Connor on there. He's already ready. So whenever you are ready, Connor, go away.
Okay, thanks very much, Steve. So yeah, my name is Connor, and I'm going to give you a quick overview of FairTraDEX, a decentralized exchange which prevents extractable value. So the team was myself. I'm the co-founder and lead researcher, and Pork, who is the lead developer and is also the co-founder. So again, FairTraDEX, we see it as the solution to decentralized exchange MEV. And how do we do that? Well, it implements a frequent batch auction without a trusted third party. So frequent batch auctions are this really cool protocol which sort of has a unique national equilibrium in which retail users and market makers trade in expectancy at the sort of true market price. But again, depending on a trusted third party, that's how they were originally created. So to replicate that trusted third party in a decentralized manner, there's three main components. So we require zero knowledge order submission. So people wanting to trade in FairTraDEX must register to the protocol at some point in time, depositing an escrow at that time, and along with some basic zero knowledge information. Then after some period of time, again, the next big component is an anonymity set. So once you register the protocol and multiple other people register, when you want to, so the protocol itself is a commit reveal protocol. When you want to commit to an order, you are one of the N players who have previously registered to the protocol. So when you commit to your order, your identity is sufficiently well hidden, and also your commitment, because your commitment is indistinguishable. It's the hash of the actual order itself. When you commit to your order, people don't know what the order is or who you are. Two of the main components needed to implement a frequent batch auction. The final component is deterministic settlement. So because of the escrow that you deposited when you when you registered to the protocol, when it comes to the reveal phase, you are strictly incentivized to always reveal your order, because if you don't reveal your order correctly, you lose access to the escrow that you deposited. So those three combined replicate a frequent batch auction. So we have a frequent batch auction. We have people trading at the true market price. MEV doesn't exist in this protocol. So here's a quick demo of the protocol. So on the top, we have a client, and the bottom, we have a market maker. So the client registers the protocol, depositing some funds and generating some zero knowledge information. The auction starts. The client commits to buy an order for a price of 101,500 lots. And again, they use the deposit information that they generated before. You can only do that. You can only commit an order when you have the deposit made. The market maker here commits to an order, a market 99 at 101, and then changes the auction phase to reveal. Then at which point everybody reveals their order, and then in this case, the market maker comes along and settles the auction. The auction settlement transaction is a transaction that anybody in the blockchain can submit, and it triggers a smart contract which deterministically chooses the price which maximizes the size to be traded, replicate, which is basically required to implement the frequent batch auction. So FairTraDEX, it's MEV proof and it's proven. This protocol is research based. It's based on game theoretic and cryptographic guarantees. The proof of concept is built as demonstrated in our demo, and as can be found in our GitHub, which I'll link to end. The individual components are audited. So we built FairTraDEX using multiple components that have all independently been audited. So the protocol itself is basically ready to be audited and deployed. And everyone's waiting for a solution. We're all here for MEV, and FairTraDEX, we think, and it's been proven, solves MEV. So yeah, thanks for your time, and here's some information if you want to check it out.
Great, thanks, Connor. Any questions from our judges?
Yes, I'd have a question. You probably have heard of CowSwap, which also does batch auctions.
Yeah.
Would it be fair to say that like the main difference to your protocol is that in CowSwap everything is more or less transparent? So basically, anybody can see the information of like orders that are being settled on the CowSwap smart contract, or like how would you characterize it? Like the main differences?
Yeah. So when you submit an order to CowSwap, you are you're sending the plain text in the clear. You're revealing your identity and the order information. Whereas with FairTraDEX, when you register to the protocol, you create this zero knowledge information, which then when an auction starts, you send your order through a relay. So when the order appears on the blockchain, it's not all the people know is that there's some commitment, and that player who committed to that order is one of the end players who's registered to the protocol. So up until everybody commits to their orders, no information is revealed about the orders themselves. So basically, you're able to replicate this trusted third party who anonymously collects the information in a trusted manner.
And how often would these batch auctions be run? Would it be like every block, or like how
Yeah, well, like it's that's a good question, and I think there's multiple. It really depends on the use case and sort of who emerges as the big users for this protocol. But I guess one sort of interesting way would be an RFQ style, where you have a client. In this case, in the demo, the client was the one who initiated the auction. So the market maker responded. You can have multiple market makers responding, and again, in our protocol, in the white paper, we actually prevent market makers from trading against each other. So it's just the best market maker wins. But otherwise, you can have periodic auctions like end of day auctions, the same way that they're done in the sort of centralized world. But yeah, there's a lot of scope for different use cases here.
I'm not sure if Brock or Jonas have any more questions.
Not at this stage from my side.
Yep, none from me.
Cool. Thank you.
Great. Thanks, Connor. Great. In FairTraDEX. Next, we'll go over to MEV mitigation using modular DAG-based mempools. Samuel, you are next.
Awesome. Thank you. All right. Thank you. I've got a lot to unfold, so I'll go and I'll try to not speak so fast. But basically, our project is MEV mitigation using modular DAG-based mempools. Right, so there's two well-known approaches to MEV. Basically, one of them is just to extract it, the Flashbots approach, and the other one is to try to mitigate it, the chain-link fair sequencing approach. Basically, we can argue all we want about these two approaches. Our philosophical stance is just that until we actually have a fair sequencing live on a blockchain, basically, we really don't know. So all we want is just to see this happen. The problem, however, with threshold decryption and ordinary fairness is that it's very slow. So here's some basic benchmark: 21 times slower to do threshold decryption compared to secret sharing. And sometimes it requires stronger assumptions. So for example, the recent Themis paper for fair ordering requires n to be greater than or equal to 4f+1 instead of 3f+1. So there's a new solution using DAG-based mempools, which very recently came out of a Dalia Malki paper. So Dalia Malki is head of research at Chainlink. Basically using these DAG-based mempools protocols. So the most well-known of is Narwhal, which Sui and Aptos blockchain and many others are using. Which, if I explain quickly, the big idea is to decouple the mempool from consensus. The reason for this is that you can achieve network speed throughputs, as they show in their paper, and they achieve 200 to 250k throughputs for simple transactions, but at the cost of like a little extra latency. So we're talking 2 to 3 seconds instead of like 1 second. So this DAG-based mempool is you construct it basically by having all these validators share their information. And the way this is done is you first have a data dissemination step where validators send each other transactions in batches. Then a DAG-based mempool is constructing using the digest of these batches, and then votes are sent. And finally, you can reach consensus with like no extra communication because everyone is sharing this eventually sharing the same mempool. Now, the point of this is that now we have our consensus, which is modular and similar to how you can deconstruct blockchains into like modular stack, right? If you deconstruct consensus from DA from execution, here we've constructed deconstructing consensus into these 3 steps, and we're saying you can basically, because now data dissemination is not bottlenecked by consensus, you could also do the threshold decryption at this non-bottleneck step, which is the transaction dissemination. So our basic results on a local machine shows that Narwhal-TD, so Narwhal threshold decryption, it is 8 times slower than the Narwhal implementation that Facebook gave. So it's definitely like a slowdown, but it's much faster than any of the other things that I've seen so far. So next step is definitely like to get fair sequencing, we need to add the time-based order fairness. So it's missing right now. And like the real goal of this is really to see it in actual blockchain and to see real users fighting like in a real market. So Project Zero MEV Geth have just come out. It's like a super basic, there's no FSS. Osmosis has been promising threshold decryption for like more than a year now. It's still not to be seen. Chainlink, same case. So we just don't see it live anywhere. We've been talking to EigenLayer to basically have a way to integrate it by creating a market on top of Ethereum to have our protocol there. So those would be like amazing next steps that we would like to see happen. So thank you. We have a GitHub if you want to see all the gory details of the architecture and everything. Thank you.
Thanks, Sam. Yeah, you can post that right in the chat if you would like for the GitHub. Any questions from our judges?
Will do.
I guess I'd have like kind of a more general question, like I don't really have a good intuition of basically how, like whether that's already tractable to be implemented in a real blockchain, or if you have like anything that like you think you'd have to improve before actually bringing it on like either EigenLayer or Osmosis. I'm not sure. Do you think it's more or less ready, or are there things that you would definitely have to improve?
Right. I mean, okay, so Smedley is already integrating Narwhal, so that would probably be one of the first places, like let's on Cosmos. One of the things to improve that I overlooked the first time I implemented this, and it's actually pretty big. Basically, you still always need some kind of feedback from consensus. The problem is that if you get a validator that equivocates, right, you still basically need a feedback from consensus, because you could have a validator that sends threshold decryption shares to some validator and then a different one to another, and you just end up basically with a split, right, on who can and cannot de-encode this. I was actually talking to Sriram, and he thinks there's a way to solve this basically by having the same assumption as TEMS. If you have 4F+1, you can kind of have a sequential like double quorum. So you just require more validators, like probably 3F+1 in the beginning to sign your thing, and then you can kind of clear that to 2F+1 to actually be sure that 2F+1 of them are not like equivocating. Yeah, so there's still like a big piece of research missing here. Which is like very interesting, but it is a big yeah, drawdown.
Very cool. I think that's it from my side.
Maybe just one question, Sam. If you had to pick one chain, well, one ecosystem you wanted to implement on, which one would it be?
Yeah, I mean, okay, so that's the big question, right? Yeah, I obviously I think like I'm a big fan of just like the roll up and security of Ethereum, and I think like everything should be built on there eventually, right? Like Cosmos should become an L3 on there, and so that's why I'm talking about the EigenLayer, talking to Sriram a lot. Definitely in the short term, it's like much easier to go on Cosmos, right? Because like the ecosystem is there. But then again, like the only place where Narwhal actually exists is on Sui and Aptos, which are coming out, in the coming months. But then the problem with them, I actually talked to Evan Chung, the CEO of Sui. Problem there is just, like they're fighting their ass just to release mainnet, right? So they don't have time to listen to anyone who's saying like we need fair, like you need more assumptions on the consensus, add stuff. Yeah, so the biggest problem is just to have a space where you can fight it out, right? And I think something on EigenLayer is the place that makes the most sense to create a marketplace, basically.
Gotcha. No, that's clear.
Awesome. Thanks so much, Sam, and your team. Next, we'll go over to MEV Olympics with Franz.
Hello, everyone. Can you guys hear me?
Yes.
Okay. Yeah. First of all, thanks for everyone coming to this hackathon presentation. We are MEV NFT Olympics. And essentially, the problem that we looked is MEV education, which is kind of spread around blog posts and crypto Twitter. And what's kind of missing is like this platform that you usually have in like traditional markets like security or finance or software development, where you have like challenges and learning resources. Yes, we know it's a secretive market, but we want to basically be the resource and go to capture the flag for MEV and block building. Here you can see a block, obviously. And our idea was to make this experience a bit more, gamified. So essentially, MEV is a lot of different disciplines. If you break it down, it's like you have private transactions, gas minimization, sandwich attacks, latency. And we thought of, what if for each of like those disciplines, you would create a specific challenge. And if you would solve the challenge, you would essentially prove it by minting the NFT for the specific challenge. And I will show a quick demo of our website. It's also in the chat. So the question, of course, is who's the top of the block in 2022? And you have basically like our disciplines, like a sandwich trade, a merge trader, master of leading zeros, maybe not a good topic right now. How to play? Well, you have the smart contracts, and you basically need to solve the MEV related challenge. There's some education videos around it, or some analytics, for example, like who's the highest gas spender in the last days, which is usually a sign of like MEV. You can sign up for the next cohort, and essentially I will give it like a technical demo. So we will look at the sandwich challenge. Essentially, you need 2 addresses and need to sandwich a trade from the other address, and this will make you make you allowed to mint the NFT. And it's complete now. And if we check out the smart contract itself, you will have the ranking, and in this case, you will see the address in the sandwich NFT. And if you click here, you have like the OpenSea link for the NFT, and you can see this sandwich trader here. And yeah, so basically, this is our like there's smart contracts, but there's challenges. And if we somehow go back to the presentation,
you might just have it,
here. So it's kind of funny because we created the challenges like 2 weeks, some time ago. And if you look at the like merge of proof of stake, we had a merge NFT, and here you can see that people actually spent $50,000 on gas for minting the first NFT on proof of stake. It shows like some people actually value these challenges and these proofs. The demo you can find in the chat, and the smart contracts as well. Yeah, our future plans are some posts towards like less technical crowd for Flashbots protection and usage. Because if you think about it, many mainstream users use NFTs, but they don't actually know how to, protect their transactions. And currently we're building like platform to actually improve the user experience. So we look at data analytics, MEV detection. So more on the what happens like if you look at the transactions itself, like a data science layer on top of the protocol. And yeah, it would be amazing to also create like a mempool monitoring for more disciplines, for like the private transactions, NFT. And yeah, please follow us on Twitter. This is our team. And that's it. Thank you so much for your attention.
Great, thank you, Franz. Any questions from our judges?
I definitely recognize the need here for a resource center or you know, whatever you want to call it. I mean, that's definitely, I mean, there is a bit of an opaque world maybe, but what's the, I mean, how you think about the startup, the project you're building in terms of future, you know, you're building a resource center, but do you have any sense of how you want to drive income to the protocol if you want to, or what's the long-term vision here?
So essentially, you have, in my view, you have like specific transitions in, you know, technologies, and just like, you know, block building is a new topic. I guess, you know, you probably know that you have some talented people, but they're like kind of stuck in their traditional finance world or something like that. Yeah, I mean, I would say, you know, I would discuss it in the future, and first, you know, look at the user feedback.
Okay, that's all from my side.
Great. Any last questions?
Yep, maybe like a short, brief technical question. How extensible is the smart contract, or like how does basically registering these technical challenges, or basically these tasks that users have to complete, are they registered on the smart contract, or how does that work?
So you have to think about, you know, what's possible in a smart contract to detect in case of like MEV, and what's not. And so it was also definitely a challenge to think about, okay, you know, how to make an NFT where it's about multiple addresses, you know, trying to get the NFT first. So it depends a bit on the contract. So for example, I mean, the leading zeros one is pretty simple. You know, you check the address and you check the number of zeros, and the one, like, it depends a bit on the challenge, and you know, there you could in some way also use like an oracle for like adding more functionality to the smart contract.
Makes sense. Thank you.
Great. Thanks so much, friends. In MEV Olympics, next we'll head over to Pentaswap Partners with David.
All right. Thank you very much for the introduction, Steve. I'm delighted to be here. My name is David from Pentaswap Partners, and we are building a flash loan arbitrage bot to balance prices across various decentralized exchanges on multiple Ethereum virtual machines. So we are a team of blockchain experts who have experience in several sectors of the crypto space. We all met during our studies at the Frankfurt School of Finance Management and are passionate and consistent lovers of MEV. Did we just create another arbitrage bot? So let me explain what makes us different. So first, we have real-time data and settlement via our own node. We have a backend packing modular opportunities in a path and submitting the most profitable ones. We have a scan tool for the mempool for all networks where Flashbot isn't offering its services. And lastly, we have a gas-efficient smart contract that is swapping at low gas per swap. So not really. We're starting on Uniswap v2 and v3 and its forks. We consume around 70K gas on Uniswap and 123K on Curve per swap. And our smart contract can conduct unlimited swaps. So let me show you a profitable execution of our backend. So here you can see the functions that we have. And by running the file, the backend crawls the information from our node, computes the most profitable path, and inputs this into our smart contract. Here you can see the transaction hash 7760 with this profit in mind. And as you can see here on our gas efficient smart contract address, we made a triangular swap and consumed around 234K. This is a little bit more than 210K as you expected, because like XDAI has a little bit more. different computation regarding gas cost. What's in the future with Pentaswap? So we want to have like memory pool backrunning. We want to extend our functionality of arbitrage to cross-chain and NFT. We also want to keep liquidations in mind as modules in our pathfinding. We want to scale our subgraphs, so we want to have more nodes on more networks. We want to scale our opportunities in total and protect against back engineering. That was our presentation about Pentaswap partners. We are open to cooperate, and if you want to do so, go on our email contact@pentaswap.com and just leave us a message. Thank you very much.
Thanks, David. Any questions from our judges?
Maybe a brief question about the NFT arbitrage. I'd be interested to like what you were thinking of, like what kinds of arbitrages, because that's not straightforward with NFTs.
I know, and I understand the issue, because like most NFTs has their own ID, and you need like a specific ID for a buyer and a seller. But what's popping up now, and I can't name, you know, the marketplaces, but where you can actually buy NFTs via the floor price. So you don't bet like on each ID of an NFT smart contract, but on the whole NFT smart contract collection on its whole, and then you just pay like, hey, I want to have like a CryptoPunk for 60 ETH, and then if someone sells a CryptoPunk to you, then you get that one. And with that functionality in mind, it's also possible to do NFT arbitrage.
Yep, thank you.
You mentioned that your smart contract can do unlimited swaps. Could you talk a little bit more about how that works?
Yeah, so basically I've shown a snippet of our smart contract in the presentation, but briefly, we have a for loop, and after each swap that iterated through the contract, we remember how much we got from the last swap and use that as an input for the next swap. And with that, by sending an array as an input field to our smart contract, we can determine the length of the array, so how many addresses are in that array. And depending on the length of the array, the smart contract knows if it's like a duo swap, a quattro swap, or pentaswap, and then just uses all the information by its own and reuses it for the next swap.
Okay, thanks.
And we can do that for all the decentralized exchanges. So Uniswap v2, v3, then Curve, and then v2 again.
Great. Thanks so much, David and Pentaswap partners. Next, we will be going to Symbolic Searcher with Amy and Bill.
Great. Hi. Our hackathon project is Symbolic Searcher, and we prototyped a way to identify long-tail MEV through symbolic execution. First, a bit about the members on our team. My name is Amy. I'm a quant researcher at Onsat's Capital. Previously, I was at Stanford, and now I'm based in New York.
And I'm Bill, ex-quant research at 2 Sigma, now exploring crypto, graduated from Harvard, also based in New York. So the research problem here is that long-tail MEV is difficult to detect and quantify using existing tools like mev-inspect-py. The solution we take is to use symbolic execution. Symbolic execution is a tool that performs constraint optimization on any arbitrary piece of code, and it tests all the logic paths in a program, and it'll notice things like assertion violations or exceptions being raised. To apply this to long-tail MEV, we take 3 steps. First, we adapt some symbolic execution tool, we use HEVM, to find MEV instead. Second, for a given smart contract, we'll modify its source code so that MEV will appear as an assertion violation. In this example below, we add an assertion statement at the end that checks if the wrap ETH balance of a given user address has increased during the transaction. If MEV exists, symbolic execution will notice the assertion violation as it explores the logic tree and will output the required transaction inputs to exploit this MEV opportunity. The second problem we face, though, is that smart contract source code is usually not available to us. How can we inject our assertion statement inside? Our solution is to instead inject the assertion statement directly as bytecode using our bytecode injector function. Our complete symbolic searcher algorithm would then become first constructing what our assertion statement bytecode will look like based on the smart contract, the user address, and the ERC token balance that we want to check. Second, we'll symbolically execute that smart contract transaction with our injected bytecode inside. And if there is MEV present, then we'll rerun with our desired address replacing the user address to see if we could extract that profit instead. We built a proof of concept searcher that detects long tail MEV using this algorithm.
The example we demonstrated Symbolic Searcher on was this case study, Ethereum as a Dark Forest, which was published by researchers at Paradigm. In this case study, there was an MEV opportunity from someone sending $13,000 of LP tokens to a Uniswap pair contract, which anyone could take by calling the burn function. In order to rescue the funds while minimizing the chances of getting front run, the white hats at Paradigm deployed this getter contract that obfuscated the MEV opportunity by calling the burn function through an internal transaction. But now we show how to find this obfuscated opportunity through Symbolic Searcher. First, we inject our assertion bytecode into the target getter contract bytecode. This is done with our independent assertion contract and our bytecode injection script that modifies the jump indices in the target contract to jump to parts of our assertion bytecode. Then we run symbolic execution on our customized bytecode to find the correct MEV opportunity. You can see here that it identifies the correct transaction inputs that would violate the assertion that we injected. So symbolic execution shows that MEV can be extracted from this contract. And from here, we just have to change the original require statement in the target contract to our desired address so we can capture the MEV opportunity with our own address.
We're looking to collaborate, and we plan to apply for a Flashbots grant to explore two directions. First, to use Symbolic Searcher as a tool to quantify historical long-tail MEV and to join existing tools like mev-inspect-py and the Clockwork Finance framework. Second is to develop the Symbolic Searcher into a general purpose MEV searcher that is capable of monetizing long-tail MEV on Ethereum and eventually other L1 blockchains. Thank you.
Awesome. Thanks, Bill. Thanks, Amy from Symbolic Searcher. Any questions from our judges?
Yeah, I have a question on basically like the risk or like the risk associated with running or using these generalized MEV searchers. Like I think we've seen some exploits where like malicious contracts suddenly change behavior based on the gas price you pay, for example. And I'd be curious to hear like whether you've thought about that or if you just want to use it like as a tool to discover long tail MEV strategies initially. I'd just be curious about how you think about that.
Well, I can answer. As we talked about in our future plans, we'd like to do both. Like we'd like to just quantify which opportunities can be discovered with symbolic execution, and the other direction to go would be to build it into an actual searcher. So if we would like to take both directions. For the actual searcher, we would have to think about gas optimizations, but for just like classification and quantification, yeah, we wouldn't need to do that.
And to add on to that answer, I think it's useful to have a dichotomy of long-tail MEV into that which can be exploited in like the sort of single transaction symbolic execution style. But there are definitely forms of long-tail MEV this possibly couldn't find if it required multiple transactions, for instance. But we think that dichotomy is also useful.
Cool. Thank you.
Quick question from me. So in the part where you inject the bytecode, looking for wrapped ether balance update, is there any thoughts? Do you have any thoughts about generalizing that portion and potentially, generalizing the aspect of which contracts you're checking and which assertions you're making?
Yeah, so I can answer that. We've built the scripts so that they're generalizable to really adding any assertion statement you want. And in the future, I think we're trying to build it out so it can handle injecting not just one line of like Solidity code like an assertion statement, but possibly multiple lines. But the way we built it right now, you can check any token balance for any address, and you can look up beforehand what the previous token balance was, so you save on gas there. And it can support any number of these sort of assertion statements, so you can check that other balances didn't go down when your wrapped ETH balance went up.
Yeah, and generally there are some heuristics you can take to figure out what your assertion statement can be. For instance, check all the storage variables, like anything that the contract interacts with. That kind of thing would be what you want to check when you when you inject your assertion statement.
Awesome, thank you.
Awesome. Thanks so much, Bill, Amy, with Symbolic Searcher. Next, we'll go to predicting MEV as a continuous variable with Brian.
All right. Hello, everyone. Our project is a study on predicting maximal extractable value as a continuous variable. I'm Brian Ide, and my teammates are Abdullahi and Fermin Carranza. We all have financial and computer scientific backgrounds, and we are all very interested in MEV. So our objective for this project was to analyze how previous blocks MEV affects future blocks MEV in an attempt to predict future opportunities. So to measure the effect of past MEV on future MEV, we decided to use an autoregressive integrated moving average model, also known as ARIMA. ARIMA is a time series forecasting model that can predict future time series based on historical time series. We chose ARIMA over other models such as ARMA because ARIMA can handle non-stationarity, and we believe the dataset was likely to be non-stationary. In addition to predicting MEV based on past MEV, we wanted to take it a step further and investigate if off-chain exchange activity was an indicator of future MEV. If there are signals that MEV, or in other words, inefficiencies in on-chain markets will exist, on-chain agents such as liquidity providers may take protective steps to prevent adverse selection. So the general thought process behind the data we chose was that price discovery should happen on the high volume centralized exchanges, and the decentralized exchange prices will follow. So we use Binance and FTX as APIs because Binance and FTX have the highest daily volume. Then we requested all historical trades for a few pairs from January 1st, 2021 to July 1st, 2022. We chose that time frame because Flashbots began around the beginning of 2021, and an end date of July 1st, 2022 gave us a nice 18-month window to work with. Our trade data includes the time, order type, size, and price of each trade. And we chose the pairs ETHUSD, BTCUSD, and USDT-USD because they have high volume in both centralized exchanges and decentralized exchanges. And we chose to gather every single trade because this level of granularity permits flexibility in the analysis that we can do. And of course, we pull the actual MEV data from mev-inspect, which is provided by Flashbots. So for our analysis of the off-chain versus on-chain data, we can once again use an ARIMA model to forecast each time series. We compare a smooth series of both data sets and determine if there are any lag effects. We can then slice up the data sets and simulate various times. Then we can observe and compare sum of squares metrics, which is a measure of deviation from the mean. We came upon this research idea too late into the hackathon, thus we were unfortunately not able to actually complete the study, but we plan on continuing to work on this idea because we find it very interesting and we are very eager to see the results. Though we are not yet able to reach a conclusion, we hypothesize that there's an effect on MEV due to the instantaneity of centralized exchange activity and the time delay in decentralized exchanges as an effect of block confirmation times. We look forward to carrying out this research and reporting our findings. Thank you.
Awesome. Thanks, Brian. Any question from our judges?
Yeah, maybe a question from my side. So like from what I got, you would look at historical price data like trades on centralized exchanges, and then try to predict or like try to estimate the size of extractable value in the next period, like arbitrary period of time. Have you thought about how to measure, like what would be the metric to measure the size of MEV? Would you look at miner tips, for example, as like a metric, like because usually lots of bots bid as a fraction of P&L, or did you have any other ideas?
I think that, oh, sorry. Okay, I think that we would measure it just in terms of the opportunity available. I don't think that we will take into account what's paid to the miner, because that's independent of the activity on these centralized exchanges.
But sure. So you like, if there's basically an atomic ARB, you would look at how large that atomic ARB, like what profit that atomic ARB would yield.
One thing that we were looking at was, hey, so let's just say we came up with a filter, like how big of an order we would consider significant, and within the next 2 or 3 blocks, are people trying to front run some transactions? And if so, you know, why? Like, because you've seen a large order, so the price is gonna go up in theory. Well, I mean, it could be up or down depending on the direction of the order, right? But we were focusing mostly on buy orders. Like, hey, is the price gonna go up? And are people trying to front run that by sandwiching transactions, because people see that coming in and they are speculating that the price is gonna rise. So you're trying to sandwich that.
Makes sense. Thank you.
And yeah, I mean, we came up with 3 blocks arbitrarily, but because we had to find a cutoff and see from there.
Let's say you finish the research and the hypothesis that you have is deemed correct or true. How do you think about taking a project further from that, from a research project? How do you think about it from there?
So one thing that I'm interested in looking into is how to use off-chain data to kind of adjust, like, let's say, like liquidity positions in order to, like I said before, protect from adverse selection. I'm not entirely sure about the details, but I think that the signals found in this research should be able to carry over into that kind of research. So I think the signals should be similar, but I'm not totally sure exactly how it'll work, but that's my general idea.
Okay, helpful.
Thanks, guys. Thanks, Brian. Thanks, Fetterman.
Thank you.
We will be going next to Got MEV with John.
So when was the last time someone else profited from one of your Ethereum transactions? For this hackathon, I built a tool to help you see if you got MEV'd. So my name is John. I'm a senior software engineer. Most of my experience is in full stack Web 2 development, although I spent some time doing machine learning, data engineering over the years. I spent the last 8 months learning crypto on the nights and weekends. I'm particularly interested in ZK tech, reinforcement learning, and MEV. So I don't know about you, but sometimes when I view a transaction on Etherscan, it's a little bit difficult to tell what happens. Who got what tokens? How much was the miner paid? How does this transaction relate to other transactions? And was this transaction submitted through Flashbots? So I built a tool called gotmev.dev to help you take a closer look. So it summarizes all the token balance transfers, including internal ETH sent to the miner and other addresses. And then it includes any bundled transactions that were also submitted through Flashbots along with the initial transaction. So this is a Next.js React web app hosted on Vercel. It takes a transaction hash from the user and then checks against the Flashbots blocks API to determine if it was included in a Flashbots block. It then checks the Alchemy transfers API for all the transfer events, including ETH transfers. And then everything links back to Etherscan, and there's color-coded addresses to make it a little easier to follow along. So this is what it looks like. User just pastes in a transaction hash. They'll get some block information, including the miner, if the block was included in Flashbots. There's some transaction info about the gas used, if the transaction was in a Flashbots bundle, and how much the miner was paid via gas and direct transfer. We get a summary of the balance changes for each of the different tokens, and then the actual transfers themselves. So in this example, we can see that the contract that was called profited 2.4 ETH, and then the miner was sent 16 ETH. Then the other 2 addresses there were DEX pools. Here's another example of a transaction that was included in a Flashbots bundle, and then we can view the second transaction that was included along with it, where someone came and back ran the first transaction for a nice 1 ETH profit. So what comes next? It'd be nice to actually label those DEX pools, some nice images, and then also include other related transactions that had interacted with the same pools, not necessarily within a Flashbots bundle. From there, we could classify other MEV scenarios like mev-inspect does, and then some other optimizations to make it a little bit more efficient. So you can see my Twitter, go check it out for yourself at gotmev.dev and view the GitHub here. Thank you.
Thanks, John. Any question from our judges?
It's a neat little tool. How would you monetize it if you had to?
I don't know. I built this because I'd like to use it myself, but it would need to be a little bit more efficient too. Right now, if a bunch of people used it, it would probably fill up my whole Alchemy account. So I'm not sure.
Yeah, so maybe another question from my side. I've spent way too much time looking at Etherscan, so that's really nice. And what would be like, from my point of view, cool addition would be maybe if you could include the block builder, like with the ETH merge. Now, basically these blocks are built by different builders, and that would be also really cool to maybe add.
Yeah, definitely. It's a great idea.
Question for me. Have you thought about like potentially adding more like classifiers? Like for instance, in the bundle that you looked at, you can see all the transactions and the details of the transactions, but I think it would be cool to also see, was this a sandwich or was this a liquidation or something like that?
Yeah, definitely. This one was like a week in. But I definitely want, like, it should be possible to classify a back run, front run sandwiches automatically. And like I said, including other transactions that were directly related with the pool. Because even if it was in a giant Flashbots bundle, a lot of those transactions may not have anything to do with this specific one.
Yep. Thanks.
Yeah, thank you.
Great. Thanks so much, John from Got MEV. Next, we will have requests for order flow auctions and oracles with Jacob.
So request order flow auctions, the end game for oracles. I myself and Brian received a grant from API 3DAO to build out this MEV solution, and I'm also the integrations lead there. Ashar is an engineer as well at API 3 and doing his master's in computer science at NYU. So the problem. We all want to minimize MEV and have the value flow back to users, but a significant percentage of the value extracted is from transactions generated by oracles, not by users. So this means that since users aren't generating the transactions, they don't have an easy fix on their end, like sending them to a new RPC. They're relying on application developers. This is also causing major issues for LPs on derivative applications that rely on these oracles, as evidenced in governance proposals from SynthetX and GMX, referencing front running of Oracle transactions, both seen in the mempool and then arbitraging stale prices shown by the Oracle. What this is known as is toxic flow, and it's basically a hidden fee on all the LPs, and it makes it pretty hard to build sustainable applications because of the profitability issues there for the LPs. So SynthetX have created some in-house solutions like non-atomic swaps and introducing confirmation times at the end of trades, but this has introduced some pretty big trade-offs for users, obviously, like long confirmation times when you don't know if your trade is completed or not. And notably, this was only a solution to the front running of transactions seen in the mempool, not the stale prices, which is caused by gas constraints on deviation thresholds. So why not just send Oracle transactions to generalized order flow auctions like the ones Rook will be building? Well, this may be okay for users, but the added latency and possible disruption of having to go through a private channel before going to the public mempool is just too much of a risk for Oracle's underlying service. So our solution, a sidecar service that generates new order flow. So you can see here that a searcher can make HTTP requests to an API, and this will be like the new mempool for searchers, and they can scan for new Oracle updates that would cause MEV. When they see one, participate for an auction at our OEV relay, which sits in front of all the first-party oracles. And then winners of the auction relay will get the signed data that can actually be used to update the data feed on chain. So by operating as a sidecar service, obviously we don't affect and risk the underlying service with the latency of private mempools. We're actually able to improve the underlying service by generating more trades and improving the granularity of the feed, actually addressing the concerns that synthetics couldn't with deviation thresholds. So another important thing is distributing the MEV accurately to applications that generated it. So a problem with current oracles is all applications read from the same data feed or the same data point on chain. But to distribute it accurately, you need to isolate auctions for each of the different applications. And to do that, you need application-specific data feeds. So we found a way to do this without increasing the gas cost for the oracle or changing their underlying service. Again, the oracle can still just update a single data point and all the application-specific feeds share from that data point, but each still have their own data point that searchers can update. So we think this is a great UX for dApps, being able to distribute the MEV to each of them accurately on chain. And then the last point is copying as much as we can from Flashbots. Thank you, Quintus, and Flashbots in general for talking about centralized order flow, and want to implement competitive auctions with low barriers to entry to avoid this, and copy things like sealed bids and off-chain bids to help maximize the value for our auction hosts. So the conclusion, we're internalizing the MEV from oracles and increasing the granularity of the feed without compromising security. We're actually improving the underlying service, so we make it a win-win with Oracle, the dApps, the users, everyone. A massive boost to UX and sustainable liquidity provision for applications that rely on these oracles. So we think this is really a crucial piece of infrastructure for not only minimizing total MEV, but helping build sustainable applications like on-chain derivatives. And we think I've shown the need for this to really be developed at the Oracle layer to not suffer from all of the trade-offs shown. So future plans, we're pretty much ready to go on the solution. The next proposal will be to integrate it into the API 3 DAO data feed service, work on improving the relay, minimizing the need for trust because it is currently trusted. But an important point to make is that it cannot tamper with any of the data. It can only tamper with the MEV, which the Oracle could already do. So we're not adding any assumptions there, and researching possible externalities the system may cause. Okay, thank you for your time. I can post a README in the chat that has the diagram in more detail to look back on and links to those governance proposals I mentioned.
Great, thanks, Jacob. Any questions from the judges?
Sure. Yeah, I have a question. So you said you're looking to minimize trust in the system. What are some of the options that you're exploring or thinking about?
We haven't really looked into minimizing relay trust because the current issue is really getting data provider adoption and application adoption. And as I mentioned, we're not adding any trust here because oracles could already take all the MEV if they wanted to. So us having a trusted relay isn't like adding anything there, but we're basically just hoping to monitor research like yours and try to hopefully find a better solution there with maybe things like SGX or something.
Awesome.
I'd have a question regarding basically how you attribute these auctions, or how these auctions are split across different dApps. Like how does the actual auction work? Basically, how do you decide which dApp to forward the tip for, basically?
Yeah. So that was the big problem, is the way current oracles work is all applications share one data feed. So the easy solution to that is give applications each their own data feed and data point on chain. So you host the auctions for that specific data point. So if you know you're bidding for that data point and only one app can use that data point, you know exactly where to send all the bids. But the issue is then obviously you don't want oracles having to send duplicate transactions to update each application's data feed with the same data. So that's why we have our solution where all the applications share from one single point. So we don't create load on the network and extra operational costs for the oracle, but searchers have this individual data point. If that makes sense.
Yep, makes sense. Thank you.
Awesome. Thanks, Jacob. With the order flow in oracles, next we will go to Hollander.
Yeah, thank you, Steve. Yeah, for this hackathon, I was working on Hollander, the protocol for MEV protected token swaps. Yeah, so here we are focusing on the DEX trading related MEV. So the end goal will be here to minimize the sandwich attacks while also try to redistribute some of the arbitrage value to the traders. And initially, we are focusing more on large traders. So the solution is to use Dutch auctions, or specifically gradual Dutch auctions. So you can see on the right a rough kind of like visualization. So effectively, the price starts very high and then gradually decreases. And like when it hits kind of like market level, the trading activity starts, and it has kind of like this slippage. Yeah, so here, like traditionally, it was traders who were kind of like be required to look for the best execution of their orders. They kind of like looked for the best venue and tried to split their order. Here, actually, the MEV searchers will compete for the best execution. Also, sandwich attacks are eliminated because there is no concept of slippage for the trader here. And also, the order is guaranteed to be filled for the trader, and we can make sure that they don't have any wasted gas on failed transactions. All right, so let's see how that works in practice. So in the app, we can see historical auctions as well as to create a new one. So when we create an auction, we can specify the assets, the order size, and some auction parameters like the initial price and the length of the auction. So when we create an auction, we kind of like can double check that everything is okay, that the parameters are correct. We also see like how the price will change over time. And then we can kind of like actually initialize the auction and start the price to be decreased. And here you will be able to see that the price will start to decrease. Here you can see like, and like when the auction is initialized, the searchers will start to monitor the auction. And when kind of like the auction price will be below the market price, they will start to partially execute the order. And here is the kind of like this demo searcher. You can see that we start to have the swaps, and when the auction is fully finished, it stops and the user can withdraw the proceeds. So there are many ideas to how to like further improve the product. So I would like to focus on like making this into more like a production product. So we'll start with gas optimization. And also we are thinking more about like how we can add more protections and flexibility for traders to make sure that they get the best price. And also thinking about pooled auctions for smaller orders so that many smaller traders can execute with a single auction. Thank you.
Thanks, Timur and Hollander. Any questions from our judges?
Yes, I have a question. What happens if basically the auction ends, but nobody has taken the trade? Does the order expire, or how does this work?
Yeah, so in this initial kind of like proof of concept stage, we don't have any protection, so the price kind of like slowly goes to zero. So in like general market conditions, we can expect that at lower price, it will be like, if we have kind of like searcher awareness, we can be sure that anyone will execute. But just to be like double check, make sure that the trader won't be executed at very low price. We are looking about like adding some like minimal executable price, and below that it will just stop, so that no one can kind of like I guess a malicious actor won't be able to kind of like execute at very low price.
Makes sense. Thank you.
Great. Thanks so much, Timur and Hollander. Great presentation. Next, we will have adding liquidity classifier to mev-inspect-py with Atharva. You are next.
So just a brief introduction about myself. I'm from India. I finished my graduation last year from the University of Mumbai with a bachelorate in engineering. And since then, I've been delving into blockchain. This is a research-based project that aims to shed a light on the MEV found in the liquidity protocol. Just a brief on the liquidity protocol. It's a decentralized borrowing protocol that allows you to borrow loans as LUSD stablecoin against collateral Ether. And this is maintained as troves in an active pool contract. And there's also a stability pool contract that burns deposited LUSD tokens to repay the debt of under collateralized troves. And it also has another second layer mechanism called a redistribution mechanism, where all the data and collateral are redistributed to the troves when there is insufficient LUSD. So the problem statement can be summed down to the trove manager contract of liquidity to these three liquidation functions. The first one is a liquidate function, which is used for a single trove. So for every liquidation, we fundamentally know two things: that LUSD tokens are transferred from the stability pool to the liquidator, and this can be tracked by adding a new transfer spec for the LUSD token contract that uses the return from pool function. And the second thing is a collateral is transferred from the liquidated trove in the active pool to the stability pool. And this can be traced using a simple heat transfer from the active pool address to the stability pool address. For a regular batch liquidation, the process remains the same since it takes place as a single transaction. Only the multiple addresses can be acquired from the trace inputs. For a liquidate troves function, we don't explicitly define the trove addresses, so we have to trace down the penultimate function called to close the trove, and it comes down to the sorted troves contract of liquidity, the remove function address. So we define a spec for that and a function for getting those addresses. While doing this project, I also happened to find an issue with the Aave spec where the mev-inspect wasn't able to detect the liquidations that were taking place when each was borrowed against an ERC20 collateral. So I narrowed down on the reason, and I was able to find that the transfer file is able to detect a simple heat transfer when the input is 0 and an ERC20 transfer, but it can't detect a low-level call such as the liquidation call used for the Aave lending pool contract when the input is non-zero and an ETH value is sent along with it. So a simple solution for this was to check when the trace value is greater than 0 and the debt token address pointed to the reserve address. If these conditions are satisfied, then we have a liquidation and the liquidation classifier is returned. So this is just a little demo to show that everything is working fine. This is the block where an Aave liquidation wasn't being detected, and after the changes, they're being detected now. So this is the block where the liquidation wasn't being detected initially for Aave, and now we can see this is a liquidation is being detected. And these are just blocks where a liquidation happened on the liquidity protocol. So as we can see here, each liquidation is being detected now, and a liquidity classifier is working properly as well. We can see all the different kinds of liquidation using batch liquidations where we have multiple addresses. And for the future plans, the first future plan is to raise an issue and send a pull request for Flashbots to review. And eventually, when liquidity starts being used by more people, we might need a separate schema to handle the multiple troves and the multiple rewards. And apart from that, as we know, liquidity provides incentives in different forms, different cryptocurrencies. So we might have to develop a logic for that as well. Thank you.
Thank you. Any questions from our judges? Okay, great. Thanks so much, Liquidity Classifier and Itharfa. We will head to our last presentation of the event order flow auctions relay with Dimitri, and that will close us out.
Yep. Hi, everyone. I promise that's the last auction you'll hear about today. So let me start. Okay, so I want to give a brief overview of the order flow auctions relay we've built for this hackathon. We are basically a team of 2 data science grad students at Ukrainian Catholic University, and also as our full-time activity, we run some long-tail MEV strats. So the problem we are solving here is exclusive order flow in Ethereum PBS. It's been a hot topic, and the problem is basically that some wallets or RPC providers might sell all their transaction flow to a single builder, which puts the latter in a dominant position and leads to builder market centralization. This has some serious negative consequences. One of them is that this builder gets to keep most of the MEV profits here, and instead of users or validators. The solution to this problem is to create some kind of market for transactions here and make builders pay to include transactions in their block with some type of an auction. And that's what we are building here. So I'll jump straight to system description. This small video will illustrate my words. So we've built a transaction relay. The builders who want to participate in such auctions may register here for now on permissioned basis. Yeah, and then they get access to users' transactions. The transaction signatures are initially hidden from builders, and they bid the maximum amount they're willing to pay in order to open them. The auction house then collects all those bids and settles auctions for all transactions independently once per each slot. The builder then may query the signatures of transactions they won in that slot, as well as the total payment amount. They then may or may not include some of those transactions to the block they sent to a block proposer, but they must include the payment for all transactions they won in that slot. Otherwise, they lose access to the relay, and we made it to keep the incentives correct. Yeah. And if you want to read more details about the system, auction format, and incentives, you can take a look at our GitHub repo. I will send the link shortly. As of our future plan, we have some general questions we need to handle. The first one is what to do with auction revenue. This is underspecified for now. We can send it to donate it to public goods or redistribute it back to users. Or something else. Yeah, the second question is what is users' value? Yeah, why they would choose this relay. And also we have some technical questions we need to handle. First one is try different combinatorial auction formats that would work better for non-independent transactions. Yeah, and also need to somehow reduce the trust assumptions on the relay itself and also on the builders, and try different payment enforcement mechanisms that allow for permissionless builder registration. That's probably all on my side. I thank you all for attention. Thank you for a great hackathon, and special thanks to Armed Forces of Ukraine for keeping me alive to this day. Thank you.
Awesome. Thanks, Dimitri. Any questions from our judges?
Yeah, just wondering where your thoughts are at right now for decentralizing or reducing the trust assumptions that you described. Obviously running the service itself for the order flow auction. How do you think that could be decentralized or get closer to it?
Not sure about decentralization for now, but one idea how we can reduce at least the trust assumption from on the relay is that the user withholds signature from the relay itself. Yeah, and then sends the signatures directly to builders. That's probably one vector to think about. And the second idea we had with different payment enforcement mechanism that doesn't require trust to trust builders, but sort of builders deposit their funds into some non-controlled contract. Yeah. And then they can give the signed permission to the relay to withdraw some of the funds as payments. Yeah, and this way builders can register permissionlessly, and yeah, so we do not need to require trust that Flashbots did in proof of work Ethereum. Yeah.
Okay, cool. And then just one more question. So do you have any ideas about how this kind of system could offer users, for instance, better execution or MEV kickbacks, or just general UX improvements to the user?
A few ideas in terms of distribution of MEV back to users. It's relatively simple. Yeah, the users that generated transactions that generated more MEV get a larger part of revenue. And in terms of better execution, I guess the users can specify their preferences, like what they want, faster execution or non-sandwiching or something else. And this transaction then would be broadcasted only to the builders that agree to these terms.
Great, thanks.
Thank you.
Awesome. Thanks so much, Dimitri, with the order flow auctions relay. This concludes all the pitches today. congratulations on everyone presenting. Very well done. Now we will start breaking out into a breakout room to deliberate. OMG, if you can do that, or maybe make me host and I can do it and add you guys.
Yeah,
Let me know.
I will give you the host as I cannot, I think, move myself, I think. Let me give you the host. Wait a second. Yes.
Awesome. Thanks, everybody.
Sorry, how long did you say?
About 10 minutes.
All right.
And we'll be back and we'll still chat here and continue. But in 10 minutes, we'll be about back to present those winners. But congratulations, everybody that presented today. Again, amazing hard work over the last, 4 to 6 weeks here. It's coming to a close. Finally get to, present, gain some traction, showcase what you've been working on, which has been really fun, really engaging. I know I've got to meet, a lot of you over the process throughout the weeks, see kind of how you evolved and built and created. We will have more hackathons here in the future. If you are interested, please, stay up to date. I think we've been kind of posting. We just started a Harmony hack, and that will be updated here periodically. Anthony, I see your mic is open. Do you want to say any words?
Yeah, I'll say a few words. Hi guys, I'm Anthony, CEO of Encode. First of all, well done for all your hard work throughout this program. It's been actually one of my favourite I think we've ever done, really. Both the fantastic educational piece by Flashbots and then the brilliant hacking that you guys have done. Certainly a sort of fervent energy around the educational events in particular. This should not be the end of your journey. This is merely one step in your Web3 education. Some of you are quite far down that process. Some of you are just beginning, and Encode is there for you in both cases. If you are near the beginning, come back and do more programs. As Steve mentioned, we have many hackathons coming up and starting. Maybe Steve, you can drop some links as I talk. The Harmony hackathon that started on yesterday, but you can still join it. We have a Starknet hackathon coming, a Layer 2 hackathon coming, a Solana hackathon coming, and many others. Accelerators, Women Build Web3, Algorand. We have boot camps. We've just announced our Denver, ETH Denver focused. It's just people intending to go to ETH Denver. 8-week Solidity boot camp. We have other Solidity boot camps, Expert Solidity, ZK, Solana, and many others. So there are many opportunities, and it's all free and accessible for you. Just come, put your time in, join live, and do great things. But if you're towards the end of that funnel and you are ready for your next steps, Encode is also ready to help you. We've had over 58 companies, very specific, come out and raise VC funding out of Encode, which we're very proud about. It is, Vignesh, still possible to register, so please do, and we will onboard you. It's a nice 4-week hackathon, so plenty of time to get involved, even if you've just missed the start. But if you want to start a company, come speak to us. We're always very happy to lend support and help. We are also very good at getting you jobs. So if you are looking for a job, please drop Steve a message, and he will put you in touch with our head of talent, Laura, who can help you through that process, minimally give advice, and maximally introduce you to a great company that is hiring. You should consider working for Wintermute and Flashbots. They're both hiring. And you should therefore apply to the jobs, apply through Encode, visit the Discord, and we'll go and speak to Laura Wiltshire, our head of talent, who will help you at least be considered for those jobs. So that's the basics, guys. Now you will receive a special NFT for being part of this program. A feedback form will be sent round for you to get your NFT. And there is also, if you've done any previous Encode programs, there's a link on I think it's been emailed round, but I'm sure Steve can drop the Medium article. It's also on Medium, and please do join that. And make sure you've got your NFTs, which will be a representation of your achievement within the Encode programs. Cool. We're going to wait now for a few minutes for the final prize winners to be decided, and we will, I think, probably in the nicest way, put the elevator music on now, Steve, and let you wait for the judging decisions.
If you have any other questions, don't hesitate, drop them in the chat to hear. But great work, everyone. We will also have a write-up about the event here later. So please check out our Twitter as well as our Medium, and that will showcase kind of all the cool projects here today, as well as please check out their GitHubs that they posted in the chat. They put a lot of hard work and want to show them off. So fun, cool way they get to do so. So thanks to everybody who's dropping theirs in the chat.
Also, guys, if you have a Twitter, drop your Twitter in. We like to follow you all. So put it in, give each other a follow, and spread the love a little bit. Believe we have the winners. We'll wait for the judges to come back.
I can close all rooms. Awesome. Looks like they have come back from Deliberation. We are ready to announce the winners. Drum roll, please, everybody. With third place in $2,000 or British pounds, request for order flow, auctions, and oracles. Congratulations, Jacob, third place. And with second place at 5,000 British pounds, FairTraDEX. Congratulations, FairTraDEX. Connor, if you're still on the call. And big round of applause for first place with Symbolic Searcher, 15,000 pounds grand prize. Big congratulations to everybody participating and winning in today's hackathon. Big thank you to our sponsors as well for joining, and all of our judges. Jonas, Felix, and Brock wouldn't be possible without you guys. Thanks so much, everyone. Would love to get a last photo with everybody's cameras on, smiling, fun faces, so we can post about this event. So everyone, please put your cameras on for one last second so we can get a nice little photo here.
Everyone put cameras on, please.
We almost got a few more. Let's go. Jacob, John, Fetterman. Couple more. Let's see here.
Everyone, cheese.
Cheese. Thanks, everyone. Get a couple there for y'all. But again, thanks. Congratulations, everyone. Thanks again, Wintermute, for our title sponsor, and Flashbots for our educational sponsor. Jonas, if you want to say anything, or Brock, or Felix, you're welcome to. But thanks for joining us today.
Yeah, thanks, guys. Thanks for the amazing submissions. Pleasure to be judged today.
I got front run. Great job, everyone. We really enjoyed reviewing your submissions. It was honestly really hard to pick the top three. There were a lot of really great projects and a lot of really great work that was done. So even if you didn't win a prize, great work. Keep working on it and keep pushing. We really enjoyed the submissions, and great work.
Awesome. Thanks, everyone. Thanks for a great event. We'll see you all later. Bye-bye.